Hello, everyone. This is Joachim Stroh from Brooklyn, New York, and we are here to continue our conversation about the social ledger, the next generation social ledger. So in the recent conversations, we left the high-level playing field of the conceptual model, conceptual framework for the social ledger, and we're now into a deep dive into sort of the development environment, right? So how are we actually going to implement this thing? And we started that with the last session, and this is kind of part 2 now, where we talk again about the different development tools and kind of ways how we want to draw people into the active development of the social ledger. And today, John Grant will talk to us about web components. So we've started the discussion last time. I talked about Meteor, so this is more of a web framework, and what are the pros and cons of that. And John raised some good points that we want to talk about today in terms of what are web components. And sort of on one side we have the stacks that are sort of out there. One of many JavaScript stacks that are out there. Meteor being one of them that I currently favor. But we haven't decided anything yet, so that's the purpose of today's discussion, to dive a little bit down into what are web components and what would be a good mapping between these components and what we would do with the future version of the social ledger. So thank you for coming, and you take it over from here, John.
Okay, well, thanks for the introduction, Joachim. That frames what I want to cover today really well. Unfortunately, my day job has stepped in, so I've not had its usual excuse. I would have liked more time, but I think I've got enough really to get a flavour of what I'm trying to see, which is about what another tribe is doing with respect to front-end web development. So if I share my screen, because I'm going to need this to prompt me because I've not really rehearsed. So bear with me, folks. So what I'd like to ask first really is, everybody put their hand up if they've had experience with HTML. Good, so that's everybody. And that would include CSS, obviously, and how about JavaScript? You're not in there, Gary, now? Have you had experience, Gary, of JavaScript? No. So why web components? Joachim gave a good description there of really the state of art, where we talk about frameworks and JavaScript stacks. But what do we actually mean by framework, and why are web components an alternative, and why do I think they are a better alternative? So before I move on to frameworks, I'll just reflect on my thoughts about frameworks and why I think they are a problem with regard to the term I use, which is technical debt. So what you're doing is you're storing yourself or you're banking rapid development up front, but storing longer term maintenance problems further down the line. And there's an anecdotal story about that. If there was a Ruby developer on the session today, they may disagree adamantly, but I'll just use this as in terms of just a comparison. But Ruby wasn't really a web development programming stack when it came out, and quite soon the community fell in love with the language, but they found out it was lacking in certain aspects for rapid web application development. So along came Ruby on Rails, and a lot of people like that. I've never used it to develop a project from start to finish, but I do know a lot about it because there's lots of aspects that have come from Ruby on Rails which have been acquired by different tribes and taken forward. But the problem with the framework is, as Ruby on Rails is, everybody's moved on now. Ruby is not the star programming language that it used to be. People have migrated to either Node, JavaScript, or they've moved to Go, or they're moving to Rust. And yet there's this huge code base of Ruby on Rails that needs to be maintained, that nobody likes, nobody wants to get involved with, but businesses and collectives and communities are stuck with this code. The expense to redevelop is often prohibitive, so it makes the only option is then maintenance.
Yeah, so John, if I can jump in for a second, I can confirm that. I had my love affair with Ruby on Rails for, it lasted for about a year or so. It was beautiful. I mean, it's a beautiful language and it's very expressive. It's almost, as David Heinemeier Hansson says, it's almost poetic, right? You write poetic, code, is poetic, is in Ruby on Rails. But you're right, it doesn't get you where you really want to go, and it keeps you, the longer you stay with Ruby, the more it bogs you down, and keeping up to date with all of these packages and, things that are coming and added to, the stack that Ruby on Rails tries to become, right? But yeah, I can confirm that.
Well, that's good that we're following similar lines here, and I would now up front say the candidates for this now are Angular, React, and Meteor. All very well engineered, mind-boggling frameworks that have created a lot of websites out there, but the world is moving on. So what do I mean by the world is moving on? So we've got the anecdote of Ruby on Rails, so it's been superseded by other technologies or languages. But I'm talking about front-end development work, not the back end. Ruby on Rails included aspects to improve that. So you had all sorts of, Ruby on Rails also had a culture or an opinion about workflow, which has been absorbed by other people. But let's now focus on the front end, the browser, or the mobile phone. So what's the alternative to frameworks? So what I'm saying here is that the actual platform, I often think of a browser as actually an operating system. It's incredibly complex system. It includes a graphic engine, it includes a runtime, it includes a language, it includes style, and it's constantly under attack for security threats and issues. Google have gone as far as creating the Chrome OS laptop, which is essentially Chrome as the whole operating system. So it's kind of a different direction to where Android is going. So they're just trying to see is, can we create a whole operating system that's purely based on a browser? So platform, what do you mean by platform? So any platform that, when I say platform, I mean something that you build applications on or build solutions. So I'll just pick a few examples. We've got Node, Python, Go. So they're development platforms, but there's also operating systems, Linux, Windows, Mac OS. You can see the slides. And each one of these has their own standard library. So you've got a crypto library, dealing with child processes, dealing with buffers. You get the picture. there's a huge amount of code here, but nobody in their right mind would try and reinvent this. They would cherry pick what they want to use to then build either another function or another package, or they would use all these modules, packages, to build an actual solution themselves. And the same goes for Python as well. Python's standard library now is ginormous. It's eye-wateringly massive, but it's full of code that has kind of formed almost organically. We need this, we need a tokenizer, we need, I just saw this, we need zip. So for creating and opening and testing zip archives. And the same with Go. So this is going back to Ruby on Rails. I argue this as well, is you can actually create web applications without a framework in Go, because they've included everything that you need to do that. So going back to Ruby, Ruby didn't have that, so it justified having a framework. If you can't do it in the base or the standard library that comes with the package, the language itself, well, yes, maybe we need to create a framework, and then the justification for other businesses or collectives or startups to say, okay, we want to use Ruby. Ruby doesn't have all the functionality that we need to create a mobile application or a web application. So we're going to have to pick a framework in order to get the job done. So my argument is the browser now, we haven't got there yet, but the browser is heading in a direction where frameworks aren't needed. And one way of being able to fix that problem is using polyfills. So what polyfills do essentially is create a level playing field for developers. So the most well-known polyfill is jQuery. So jQuery allowed you to select nodes or elements or a group of elements using almost a query language, which is now called CSS selectors. But jQuery itself, there are other aspects to jQuery, but that was the main reason for its original creation. It's no longer needed anymore. Browsers, modern browsers now can provide the functionality that jQuery was originally created for. So if we're not going to use frameworks anymore, and we're going to use polyfills, what do we need to look for? So I would use, it's not my opinion, this has worked since the 1970s. So you could go back to the 1960s, the Unix philosophy. So any useful program or library or package does one thing, but it does it well. And really, one person or a group of people can never do that. It actually develops over time in the community through iteration after iteration after iteration. So you end up with millions of man hours, people hours, going into the development of these useful, minimalist, modular APIs, packages, or libraries. Now, does that make sense to everybody? Yeah. Okay.
Yeah. So, John, one thing about the polyfill discussion, I don't know how far you're going to dive into that area. One of the leading groups here is this Polymer, approach. And so what I've seen over, a year or two is, they're filling in, as you mentioned, the gaps there, right? So it turns out if you look at the latest, I don't know what it is, 2.0 or 3.0, it looks like to me all of the gaps have been filled now, and there's nothing left to do almost. If you see all these green check marks on their matrix, tables that they're sharing at these conferences, what is the role? What do you see is the role then of polyfills in the future?
You will always need polyfills. I don't think they'll ever go away. As long as there's human endeavor to innovate, because we use more than one browser, browsers will all be at different points of the development life cycle. So in order to create a level playing field, we need polyfills. Also, Google wants the internet to work. If the internet is failing, Google fails. So that's why they foisted Chrome on Microsoft. Microsoft wasn't pulling the finger out. They weren't iterating enough with Internet Explorer 6. They hadn't released a new version for years. So Google wasn't prepared to sit back and let that happen. And the same with all other aspects, including WebRTC and web components. Google are trying to push the agenda forward, but there is reluctance from other browser vendors. Obviously, there is the cost, budgets, how much time it takes to do these kind of things. But also legitimate, so I'll say they're not legitimate complaints. They're just people making excuses. But Google don't always get everything right. They do sometimes steam ahead. If you look at the first version of Angular, for example, there was a lot of decisions made in the framework which they've now regretted. So Angular 2 is almost completely different from Angular 1, which has alienated a huge section of the development community. They just got sick of the fact that you would get used to one framework, understanding that's the way things should be done in the future, for it can the rug taken from under their feet. So with all good open source projects, people won't sit back and allow that. So you have Vue.js, for example, which is, we're going to stick with Angular 1, whether you like it or not. And that framework should be able to morph and take in aspects of web components if you want to go down the framework route. If you're single-minded, that's all I want to use is a framework, I want to stick with Ruby on Rails, well, there will always be people out there that will take the time, or communities, to do that. But there's a more important, and I hope by the end of my demonstration, so I've got 20 minutes already, so I need to press on a bit. But polyfills are one aspect. More important to me is how you approach your development workflow, or the engineering, the software engineering. And this is where the technical debt can be tackled, dealt with decisively. So with going back to Unix, one of the things about Unix is grep, for example, fantastic, useful utility, can be chained together with other commands, and you can almost create fully functional applications. So you can create import scripts, ETL scripts using grep. So the first point here is code reuse. So you want to be able to pick libraries and modules that you can build upon to create reusable code. With frameworks are offering a structure. This is our structure. This is how we believe things should be. Angular 1 mentality. In order to get to that stage, you have to bake into the framework opinions. So frameworks are about offering a solution. They're not about offering useful, reusable code or APIs. And that's the big mistake. That's the piece that people don't appreciate. And that's what's really brought me here today to make this presentation. The other thing about software engineering approach to writing front end, this happens on the back end. It's happened for years. And I will show you in the demonstration next exactly what I mean. But it's composition. So what I mean by composition is where a team of developers can create their own reusable libraries and components, which the other members of the team or other bits of the organization or other communities can then use to build their own solutions. So going back to the Linux philosophy, it's a library that does one thing, but it does it well. It doesn't try and introduce any other things. It doesn't try to change the way things should work. It just does one or a few things, a set of things very well. So once you've cracked that, so if I just step back a minute, one good example of polyfill chaos is NPM. It's full of things that browsers can't do yet. Lodash. The list is endless. So all they are reusable bits of code that you can use in composition. So think of Lego blocks, or think about a car. So a car has a chassis, a gearbox, a drivetrain. Now, if Volkswagen are creating a new car, they tend not to develop every component. It will be farmed out to other suppliers. And if that relationship with the supplier changes or technology moves on, they want to be able to swap out that component and insert another one that is either cheaper or is more efficient or meets regulatory requirements without all the fuss. So you can't do that with Ruby on Rails. You can't take bits of Ruby on Rails apart. You could do if if money was no object and time was no object, but you're stuck with that entire stack. And you stuck with it throughout its whole life cycle. Your project lives and dies on the fortunes of the framework. And one of the most expensive and disappointing examples of that is Angular 1. The other thing you've got to do, I want to really drill home here today, is productivity. So I started this conversation saying that frameworks really help accelerate development in the first instance. I would actually disagree with that, but I understand the rationale. So you could almost say, well, okay, well, frameworks are good for prototyping. Yes, that's their only use these days, as far as I'm concerned, is to quickly get, so they're up and running, there's a demonstration, a wireframe, here we go, does this work? Yes. What did you use? Angular. Right, throw it away now and build it properly. And you want to be able to build something that can take advantage of all modern software engineering principles. You want to be able to automate the build process. You want to be able to automate testing. You want to be able to automate deployment. Because if you can't do any of those, you shouldn't be doing software development.
Yeah, so John, one thing you mentioned that last time too, that you say that web frameworks are used for prototyping. What I'm wondering is, then why would people start using frameworks if they know they're going to go away after they move to some kind of a production environment at some point, where this framework might be too fragile or might not support the solution they want to create?
All I can say is I'm trying to tell people about it.
Okay.
People.
Well, can we maybe move on then to the transition model? Because clearly we're in a level of framework at this point. And I think the issue I think you made the point really well, John. There are limits and there are technical debts. Now, what's the alternative that's immediately before us?
Well, I'm not here to spread dogma. All I'm going to do today is just to show you perhaps what another tribe is doing in terms of front-end development. One approach is to use the platform. I've already explained that if you're building on Windows or you're building on the Linux kernel, you don't start rewriting the Linux kernel. You just use the Linux kernel.
Right.
And what frameworks have done is fill in that missing bit. So you could argue that the memory management for a certain scenario in Linux wasn't there, so somebody built a framework to do it. But once that's been baked into the kernel, the framework has to go. The problem is if you invested time and experience and you have a system that's cost hundreds of thousands of pounds to develop in a framework, you can't take the pieces away. I've already explained that with the car analogy.
But here we haven't invested hundreds of thousands of dollars in anything. Just Joachim's been working his fingers off coding this stuff. So, you know.
Yes. So as I say, I'm not here to convince anybody. Really, I'm here.
Please, I think you are convincing, John. I'm not well convinced. I mean, I'm done with the convincing. Okay. I want the proposition.
Well, I would, when I get to the end of this, I will.
Oh, I'm sorry. I want to get to the end. I want a framework. Please, quick, give me a framework here, John.
This isn't a silver bullet, by the way. Software development actually is getting harder. It's not getting easier. And that's why I'm saying if you take the engineering approach to things, at least you're trying to mitigate that kind of stuff. At least you're trying to mitigate, you've got to start thinking about configuration management. You've got to think about audits. What happens if we had a security breach? How do we onboard new developers? If it's all about having a framework, again, the framework is about how things should be structured. Well, I've already talked over the fact that things are moving so quickly that frameworks get outdated. Ruby on Rails, Angular. I mean, they're the biggest examples of risks associated with adopting frameworks I can come up with. So let's jump into these few demos that I've got. Again, this has been a rush job. It's not the way you would normally do things, but what I'm trying to do here now is just to give you a flavor of how web components work and how a polyfill makes your life easier. So a polyfill does two things. One is it takes the rough edges off browser incompatibility, but it also introduces syntactic sugaring. So it allows you to use shorter, terser code structures to get the job done. And I'm going to show you a brilliant example of this now. You can see this example in all other frameworks like Angular and React, but it's just a way of saying, well, Angular and React are actually doing that themselves. The framework, the JavaScript, they've had to build that from the ground up to do what I'm going to show you now, which is actually baked into the browser. So I'm jumping ahead of myself and I've lost my thread slightly, but I hope you can see this, that web components are really, it's an umbrella term for lots of different things. But once I've listed them out to you now, there's the four there, you'll never actually think of these again. It's just that these are the specifications. This is what we're talking about. But when it comes to actually coding, you don't think in these terms. You don't use these, well, you'll say custom elements, that's obvious, and we'll come on to that in a minute in the demonstration. Then there's Shadow DOM. Well, Shadow DOM, you never think about it. It's just there and you're using it. I will show you how the Shadow DOM is helping and it's making life easier, and it allows us to create reusable, testable, isolated components. HTML imports, again, you'll never think about those once you start developing, and that's HTML imports is actually where the contentious issues have been between Mozilla and Google. And Mozilla were right. They said HTML imports is the wrong way to go because Harmony is going in the direction of imports, and the same with CSS. HTML is just a quick fudge that hasn't been thought through properly. Hallelujah! At least the Firefox is there to keep the people on the straight and narrow. So this is just like another wrinkle in the road that we just have to get through, but polyfills help with that. And the last thing, which is one of the most important things, which I'm going to demonstrate now, is HTML templates. So this is a way of being able to retrieve data in any format. So the most popular at the moment is JSON, could be XML, and it could be a lot of things. So when you're creating single page applications, what I'm going to do is I'm going to keep going, because if you get terms that you don't know, it's going to be a waste of time. All I'm trying to do now is just so you get the gist of it. So if you're creating single page applications, you don't do browser refreshes, you just pull data from the server that tends to be in JSON format. So you won't be able to see that, so I'll zoom in and let me know if, can you see that now? Can you read the text? Yeah. So everybody's familiar with HTML, so you can see here the usual tags. One thing we're doing here is importing the actual cross-industry web component polyfill. So this is the thing that's giving us browser compatibility and should eventually disappear over time. But it doesn't matter, to be honest with you, because you don't think about it when you're using the coding approach I'm going to explain. The next thing is Polymer, which Joachim raised before, which is Google's attempt at providing a productivity layer, syntactic sugar, which I'll show now. So one thing that people don't realize when they start creating web components is you can actually build them in line in the page. So you often think of web components as being in separate files that you import into the browser and then you start to use. Well, I'm here to give a demonstration. I was in a rush to get this finished today. So what I've done is I've built these examples in line. So you can see there's the two imports that we need. There's a usual H3 or H1 tag for the title of the page. That's the web component there, line 20. And line 61 is the custom element being used. So there's two bits. One is the definition of the component, or in this case, it's a custom element. So if I say components, I'm talking about custom elements. So you actually create your own HTML tags. So there's a P tag, the div tag. Here I've created one called X custom. With the standard web components, you have to include a dash in the name. So that distinguishes it from being internal tags as opposed to custom elements. So to get on to, I'll quickly have to run through what's inside a custom element. So there's a template area here, then there's a script, and then there's the actual definition of. So this is the bit where you're communicating back to the browser to say, look, I've now created a new tag and I want you to be aware of this. And when I ask for it, you know how to render it as above. The actual tag is defined here inside this template, and you can include style. Now this is where the shadow DOM kicks in. And this is the only time you will probably hear somebody talk about it. But what the shadow DOM does is it isolates the DOM that's in the browser, which is where the body tag starts here, to this DOM module or HTML custom element. So anything that's defined in here doesn't have any cross-play or side effects with the page itself. Excuse me. So I can start to style these elements that I've included inside my components. There's another H3 in here, and I've given it a color. But what you'll find is it doesn't affect this H3 that's outside the component. Now, it doesn't matter whether it's in line like I've done here, which you'll never see. This is just a way of being able to demonstrate, and I use it to actually code this way as well. And then the second part of any web component is the actual logic. I'm going to get stuck here. I've got a frog in my throat. So what's in here at the moment is boilerplate. So I'm not going to talk about it. Just accept it as that's what you have to do when you're building a custom element. You extend, in this instance, the Polymer element, but you can quite easily just extend HTML element. So if you're doing raw web components, I could extend a P element or a div element. So I've shown you here how the shadow DOM kicks in or comes into play, and I'll show you here how templating works. So everybody's probably familiar with Mustache. So here, this is where templating works. When I run this, what's going to happen is there'll be a text box that when I type into it, it will be reflected inside this div. Polymer behind the scenes creates a getter and a setter for this foo variable. I could define it here, but I'm lazy. I haven't bothered. But in the examples that will come, I'll show you how that's done. So foo is a variable, and foo is listening to the input event of a bog standard text element. Nothing fancy. And whatever is put inside the foo variable, the foo will be surrounded by an observer. So any templates that are listening on that will stamp that out in the shadow DOM as well. So if I run this by so first thing to notice, you see the two different styles for the H3, completely different, isolated. And here, if I type something in, you'll see that it's being echoed. You might say, wow, that's magic, John. But to actually do that in JavaScript is an incredibly challenging task. There's also nothing stopping me from adding as many observers as I like. So if I add two more, save that, go back, F5, and you'll see that there. So that's Shadow DOM and template from the W3C standards. What I'll show you next is, if you then imagine yourself building these components and you want to be able to set default values, how do you do that? Well, it's easy. So you see here, let me zoom in. So this is the same example as the last one, except this time I've actually created my own setter there called foo. So in the other one, Polymer created that for me behind the scenes because it was missing, but here I'm actually defining one. I could actually give it a default value here, which I've commented out, which is hello, but I'm actually going to set it using an attribute. So everybody recognizes that. So in a div tag, you would probably have the class attribute and so on. So here I've created a custom attribute called foo, and I'm setting it the default value. So if we look at that, you'll see as it's loaded, it's brought in that default value and it's set the observer at the same time. It's quite a contrived example, but I hope it's getting the point across. About the standards. Now, I'm going to start talking about the bit that's important to me, which is software engineering and Unix philosophy. And this is composition. So if I create a component, which you'll see in the last one, there's only 2 more examples to go now. Are you glad about? But in this one, I'll show you how you can create components by including other components. The term is composition, which is quite straightforward. So what I'm doing here is I'm importing an input component and an icon component, because my manager told me he didn't like the look of the last one. He wants something that's a bit more stylish and a bit more functional. So no problem. Same styling, but this time instead of using a straightforward browser native HTML input element, I'm using the paper element, but I'm doing the same listener or an observer, foo on that one and foo on the div. I'm not setting a default value, and there's no default value there. So when this one launches, it should be blank. It is. And you'll see that that's the more stylish material design input with an icon to boot. So I hope that's making sense with regard to how you can start to build bigger systems that isn't a framework, but using the Linux philosophy of let's use the best input element and let's use the best icon element. And further down the line, if that gets superseded, all we need to do is change these imports, change this, but our components and the components interface stays exactly the same. So it can update itself through its own lifetime. So now let's think about an analogy with the social ledger. So I've created a component here called an SL card. So what we would probably do in our domain is prefix all our custom elements with SL, for argument's sake. Again, I'm doing it inline, but normally this would live in a file or a set of files as the input element is done here. So people could reuse this card element many times in many different applications on many different web pages, and also create lots of instances of it as well. You don't have to create one, you can create as many as you need on a single page. This is a bit more convoluted, but I hope it does make sense once it starts to run. So I'm using binding again. I'm using or reusing custom components. For this example, I've reused material design components. And it will also call a little server I've created as well in Go. So this is, again, it's not using an isomorphic stack because that's the requirement of the framework. I've just decided I'll use Go. It could have been Node, it could have been PHP, but no, I'll stick with Node. So I'll show you that first. So this here is a collection of, there's 5 functions. 3 of the functions are just to create a toy application. To get a message, in this case it's going to be a random message, and get a user, a random user, and a random user's avatar. And it will transport that back to the browser using this Jibber struct. So the application, or the card, is called Jibber. Jibber Jabber. Now the whole web server and WebSocket server is inside this main function, which is, what would you say that is, 10 lines of code? Okay, WebSockets are complex. There's a lot going on behind the scenes, but for a demonstration, to try and do this in Ruby on Rails, it would take you a week, and then it would take you a week then to build a damn thing. Where this will build in a matter of seconds. It will create a single binary that has no runtime that can be deployed on any server, Linux, ARM, Android, Windows, whatever. So this is probably me waving the flag a bit for Go, but I hope you can see here just how simple things can be in Go world. So let's see this running then. So I hope that looks familiar. It's a mock-up of one of Joachim's cards using bits from Material Design. So obviously you click join. Oh yes, I need to do that. I don't know what template tokens is. Sounds expensive, but I'll take the gamble. It's then contacting the server, and this is just to show you how one component that could be reused and tested can work. If we agree that yes, the Jibber Jabber needs to go live, how are we going to distribute that? Well, one approach is to use GitHub and perhaps follow the pattern that Google use. So every component that you create lives in its own repo. So if we look for, I used the paper element before, which you saw, which is there. So in that is all the there's different variants of the input custom element. So if you ignore those and just think there would only be one, then you've got your Bower, which is what are your dependencies are. If you want to look at my dependencies in this application, they are here. So I'm depending on Polymer, input, icons, the card, the button, and the checkbox. You've seen all those. So you wouldn't check any of those into GitHub. You would just version the Bower JSON file. And then anybody that checked out this card component would just run Bower install and it would get all the dependencies. So in a standard component, there is a command line, which I won't go into this because I feel like I'm kind of drifting off the core subject, but you can create boilerplate either applications or elements. So there's a command line called Polymer. You say Polymer init an element, and it will create all these test harnesses for you, which you can then fill in the bits as you build out your component. So once my Jibber card is ready, I could bump it up to version 1, and then somebody that wants to build out the front end could clone this repo and then use npm to import that into their project just from the file system. They don't need to, so they could say, oh, I'm going to stick with version 1 of Jabber today. And that would then become a dependency of Social Ledger. In the meantime, this Jabber thing could be continued to be developed into version 2 or version 3, but it wouldn't break the build of Social Ledger 2 because it's a dependency that you can version. So I hope I've stressed the points about it's it's not a means to an end web components. It's about preventing technical debt and being able to use an approach that's more like Unix rather than script kiddies. I can't think of anything better. I'm a bit tired now, but I hope that makes sense, that front-end development should be easier than it actually is. And you don't need convoluted frameworks anymore because the browser does the work for you. And you'll see that if you wanted to rotate this card, for example, I wanted to do it, but I ran out of time, so it flipped around. You could use the 3D animation API that's both CSS and now JavaScript that takes advantage of 3D acceleration cards. You don't need a framework for that. It's all in the browser. It's just, it's slightly difficult at the moment because some browsers are playing catch up. But one last thing, I'll just show you here in DevTools. You can see that here in the console log, this is just logging out what's coming back from the server. So we're using the data binding. So every time a random message is generated, so there's one here from Joachim that's saying, yes, please, that was message count 116. So as those stream in from the server, there's this piece of code here. And I'll just show you how simple it is. I mean, it wouldn't be production code this by a mile, but when you went and bought you paid your 10 tokens to start to buy Jabber, it set a few flags up to tell you which card to display. It then started the Jabber listener. So it's connecting to Jibber Jabber here. That's the URL. There's a few other bits, and then it doesn't poll, does it, because it's web components, but that's it. So as it sets those variables there, so the user, the avatar, the message count, those are automatically distributed across the browser automatically by using HTML templates, which in Polymer parlance is observers, which are these things here. So you can set a flag, say notify true. So when that's true, these things update automatically. Now to do that in jQuery would be an absolute, well, you can imagine. And it would be impossible to maintain as well. See, with this, it's business logic. And what I like about, I've done this in a way that's not really the recommended way, but you can see as I set those flags there, so we're not in start mode, we're in join mode, etc. There's just simple templates that say, if truthy, as you do in JavaScript, then display this card. If this truthy, then display that one. It's almost, it becomes declarative once you get the flow going. The only bit where you don't need declarative stuff, or you can't use it, such as the communicating with WebSocket server, goes in here. One last example, and then I've finished. Previously, you would probably, in fact, I would probably recommend that I would use WebSockets here because it provides some additional syntactic sugar. But it shows you that some browsers now are capable of dealing with WebSockets directly. So it's create the WebSocket and listen. Done. And the Go server is running here. So this is logging out the messages as well. So this is like the command line that you would normally see on the Unix side. Right, I'm done.
Fantastic. I'm
Thank you.
very impressed. But then again,
Mhm.
I'm easily impressed. Joachim, you've got a few questions, I'm sure.
Okay, here's my list of questions. Okay. No, okay. First of all, thank you, John. That was great. Very enlightening, very clear, concise, and introducing web components to us here is fantastic. Thank you so much for doing that, John. And I have to say, I understand a couple of things better now. And I understand first of all, what I've seen, right? So what I've seen so far is something that's getting closer to, at par with what a framework can do, I was really surprised to see the reactive front end that you created there, using your JavaScript elements, and the polyfill elements, and in a very simple way, creating something that's already showing the same kind of reactiveness you can build with something like a back framework, right? So there's something that's getting at par here, which is very interesting, right? Of course, it's only doing some simple stuff here, but it's clear enough, to me. I mean, it's clear enough that the code reflects that pretty easily without putting too much. I was expecting that you have to put a lot more code actually in there to create this simple reactive element there, or the card that you demonstrated there. So that is an interesting aspect. I haven't considered that before. The other thing which I liked is sort of the modular aspect of these bits and pieces that we're putting together, right? So when you showed, you checked that into a GitHub environment, and then people can actually take that module only, right, and improve that. Let's say it's a Java card there. So I'm checking this out and then going into the next version here. So that kind of modularity, I wouldn't have seen that in the media environment, because there you're working always with the full stack, and it's hard to take a small piece out of that stack, right, and work on that and put it back into this. Because you have to I think you have to understand sort of the whole picture almost before you can work in that, right, environment.
Could I show you one last thing? Quickly show it to you. It won't take me a minute. I feel I could have done a better job on this because it has been a rush job, and I haven't time to rehearse the talk. But what I want to show you now is how you can start to think about components in terms of frameworks. So let me just pull up this website, because I'm certain Joachim will like this, and I forgot.
Well, if Joachim likes it, only work for me too.
Well, I don't want to exclude you two guys, but I know Joachim is visual, and that's why I wanted to. I want to show this if I can find the damn thing. Hold on, I'm nearly here. Right, these fellas. So I'm going to share my screen again, just to. I want to gauge the impact. Screen share. So, can you see that?
Yeah.
Yes.
As you can imagine now, there's a whole industry of people starting to create custom web components. Now, the good thing is people are creating them, but putting them in the public domain. One company is this Vaadin, which are European. I think they're from Finland. And I've been following these guys for about 2 years now, and we've started to use one of their components. Like everything, it's not perfect, but what I'm going to show you now is this is how you can start to think about frameworks as becoming more on the edge, or on the nodes. So, for example, a date picker. It's always, when you're used to code things in jQuery, you would only go and find a date picker. There'd be one somewhere there. And it's the same with web components that they've now started to create. So always useful, always need, especially when you're creating back-end admin systems. You want to be able to put in a date range. One of the most awful things to code yourself. So what you want to be able to do is find a custom element that you can reuse, but they don't stop at widgets. So that's the word I'm looking for. They take it further, so they've got a full-blown grid. So if you really want something quick that you can, so there's infinite scroll, stuff like that. You can enable editing. You can, my browser's being a bit slow at the moment. So as you can see, there's quite a lot to choose from. There is a line here, not everything is free, but all the good stuff is free. And where they start to charge, there are alternative solutions out there. So I'll put that in chat. So the point I'm trying to make, and I'm not making a good job of this. So dialogues, there's another one that's always useful and always something that nobody wants to code. So quickly, you've got different types of dialogues that you can plug in as a reusable component that could be swapped out at a later date for something that's better or more compliant or better cross-browser compatibility. So this is where my analogy comes in, where you can think of these as being miniature frameworks. So what you're doing is you're betting on this to do the job. You're investing in Vaadin or whoever you pick on to be your provider of the component or the module. But it's only at the edge, or it's only at the widget end, not the entire stack. The monolithic stack, that's key. Monoliths has always been a bad thing in software engineering, and that's what frameworks are. So I'll stick this link in chat and I'll shut up. So I'm done.
And that's great. And these components that you're showing here, John, so they're also open source.
Yeah.
So you can actually see the source code and make modifications to it if you want to, and so forth.
So you can fork it, or you can ride with them. Just use the. We use them for back end stuff, and tend to use either the material design. Because the material design, what's difficult in that is the metaphors and the standards that they've got for compliant and effective and efficient UI. And that's where they've done a lot of research, etc. But once you start creating, like the card example I show you, I just used the starting point of the card and then fiddled about with it to create that toy application. Mm-hmm. I hope that makes sense. I don't feel like I explain myself very well on that, but this is where this becomes the miniature Ruby on Rails, or the miniature, some of the components here, once you've had a play with it, you'll see are quite complex. They're not trivial by any means.
Right. So this is a good library, and if you have more libraries you want to share, I'd love to take a look at this to get a feel for what's out there that we can plug into the web components environment. What I also like here is you mentioned this engineering approach a couple of times in your demo, right? So the idea that you can actually swap out these components. If anything fails, a piece of this fails, you just swap it out with a better piece, right? Without going through a massive re-engineering, process here, which I like a lot. That's a good reason again why you want to keep this whole thing very modular, sort of isolated bits and pieces. You do have to be careful, I believe, to select which ones do you want to use. What patterns do you want to really enable in your application, right? So I believe there has to be some kind of agreement here, so we all read the same code and understand, that's the patterns we're using for the social ledger, versus other patterns that are out there that we could have used but we haven't, right? So I think that there's some more discussions on that end, but this is great. That gives us a great understanding of where you come from, John.
I also want to also highlight some of the warts. It's, you know, I need to be fair, and I've not done a professional job of this presentation because, again, no excuse is needed. But what's happening is, as you're giving me the feedback, I'm thinking, yes, I should have mentioned that. Yes, I should have mentioned that. So there's one thing I want to show you now, and I'll show you that it's already been solved, but not that many people realize this, or they can't actually tune into the fact that it has actually been solved, and you don't need to worry about it. Because if this was to crop up in 6 weeks' time or 12 months' time, and Joachim or Michael or Gary was to say, John never mentioned that, so I'm not going to be caught out. So one of the things is, as I was demonstrating all the modules that were being imported, there was this notion of composition. So components are made of components which are importing style sheets and other components which are all using those HTML imports. Does that make sense? Do you remember that? So if I show you in the demonstration now, I should still have it running. Oh, come on. No, I'll have to pull it up again. So let me just restart that. Let me share my screen first so you can see what I'm fiddling about with. And this, right. So I'm going to start the server again. Open this. I'm going to show you the card demonstration that I showed you before, but I'm going to open up DevTools, which everybody knows what it is. I'm going to look at the network tab. So as I open this, you'll see that there's quite a lot of files that come in.
Right.
These are all coming in through the imports. So the card component, for example, is using the tag components, which may be using the default behavior components, which is using the apply shim and the element mixins. And some people will look at that and think, oh, that's no good. How can we have performant applications that are bringing in so much code? Well, with HTTP2, that allows asynchronous, it's not asynchronous, it's multiplexing. So instead of having to create a separate connection to each server for each file, so it sees this import, so it needs to request that, wait for it, comes back, it then starts to build up the DOM, then it realizes it needs the DOM if component, so it requests that, waits for it, comes back, parses it, then it realizes. So you can imagine that's going to be a time consuming and it's going to have a hit on performance. Well, it does do with HTML1. You can, in the build process, use this thing called vulcanization. But I fall asleep when people start talking about minifying and uglyfying and vulcanization. It's tricks that you may get a smidgen of performance improvement today, but you're stacking up technical debt or you're wasting your time because it's a problem that's already been solved. If you look at, look at my, our website, for example, let's just refresh. We're using web components here, but you'll see we're using HTTP2. That's why. Can you see this, by the way, on the screen? So instead of it being HTTP1 in the protocol, it's listed as H2. So the protocol is so efficient that you don't see that overhead. It is always advisable to minify files. So if you've got a large amount of CSS, there's always a way of being able to reduce that, because HTTP2 doesn't affect bandwidth. The bandwidth is always the same. That's a fixed quota that can't be altered. But what we can do is make it much more efficient to get lots of files down to the server. So you'll see here that we don't bother creating what we used to call sprites if we just send down every individual file, because HTTP2 is so efficient at doing that. And if you look at most websites now, or most content delivery networks, if you look at, say, The Guardian, and I don't know why I've thought of The Guardian, but never mind. But you'll find that everybody now is on HTTP2. See there. So even though Web Components probably solves one set of problems, there's always the unintended consequences of it creating another set of problems here, where it's the amount of files that need to be imported for a page to actually render itself and display. And you may also think, there must be a massive dependency graph as well. So if one input element is relying on, say, the card element, which is relying on another element, and yet another component is relying on the same set of dependencies, do they get imported twice? Is the file actually requested twice? Well, the good news is no, because Web Components sorts that all out for you. So if you remember earlier when I said it's about engineering, not about trying to wring out as much performance as you can, which people do these days. And there's no point. I mean, okay, you should compress images, you should minify CSS files, but down the line, the problem has been solved. So the upshot is, if you go down the Web Component route, it's not the silver bullet, you may want to look at having HTTP services. Nginx supports it. We use Google's load balancers. So if you ever go through a load balancer, it tends to convert HTTP1 into HTTP2 as it goes out anyway. So it solves the problem for you.
Good. Yeah. Thanks, John. I mean, that's another good news story, right? And I do like the long-term aspect of that, right? So down the road, if things are going to improve, we may have some performance. We don't even know, if the social ledger has performance issues, if we have to load too many files, or once it's running, are there any performance issues with the application itself? We don't know at this point, so there's moot, I think, to talk about.
Well, for mobile, you do, if it's on a mobile device.
Right. But so that's great. Thanks again, John. So I think we have a good presentation today about an alternative path that we want to explore a bit further. And I want to bring in Jim also into the discussion, have him take a look at this, see what he thinks about it, and then we can go from there. So I'm thinking in the next conversations that we're having next week, I do want to start almost on a track for the specifications of the social ledger, right? So be more specific on what actually the functionality is going to be. We have done all the conceptual framework now. I'm reviewing that with several communities now, gotten good feedback on the conceptual side. We looked at the engineering and the development side now, and we need more diving into that area too, of course. But then what comes next to me is sort of, let's talk about the specifications. What do we actually want to create here? What do we want to implement using whatever platform we're going to use here, right? So I think that's going to be the emphasis from here on. And then to me, it's important to sort of create this minimal viable thing, call it product, call it service, so everybody can actually see it. To me, it's, I'm a visual person, so I like to put something out there for people to see it, reflect, play with that, with the minimum piece of functionality, so they can get a better understanding of what it is that we're building, right? So we're starting the feedback loops early on, and ideally get to a point where we can then start the thing itself, to help us build the thing, so that it helps us create a workspace, where we can invite people, show them, give them a tour of the facility, so to say, right? And help them on board too, right? So help them understand what we're using, what tech we're using, what methods we're using, and where we want to see more, how we want to build out that in the future. So I think that's coming up for the future sessions here that we're having. But today's session was about the development environment and web components. So thank you again, John, for the presentation. And thanks all. See you around next time, right? Okay, let me see.